Welcome, ladies and gentlemen. So what I like to do is show you how to graph a quadratic in vertex form when it's in standard form. And there's a couple different ways we could do this. Obviously, we could use some different methods to graph it in standard form. But in this video, I'm going to show you how to rewrite it in vertex form. So what I did is I wrote standard form in the blue up here, and then I wrote vertex form in here. So the way that we're going to convert this is by completing the square. Then, once we complete the square and we have the equation in vertex form, we can then go ahead and identify the vertex, identify the axis of symmetry, and then we can graph it and then determine the domain and the range. Well, we could do the domain and range without graphing it, but we want to graph it. So to go ahead and write from standard form to vertex form, to complete the square, the first thing we need to do is contain our quadratic and our linear term. Our quadratic term is our variable squared, and our linear term is going to be with our variable to the first power. So we're just going to contain these two. Now, the next thing we want to do is look to factoring out terms so our a is going to be equal to 1. Well, you can see here a is going to be the coefficient of your quadratic term. So in this case, you can see a is 1. So we're good to go on that. All right. Now, the next thing we need to do is we need to find the value that is going to complete the square. I'm about to sneeze. Bless you. Thank you. Sorry. Okay. Wow, that one hurt. So we're going to find the value that's going to create this binomial into a perfect square trinomial. And I'll get to the importance of that in just a second. So to do that, what we're going to do is take b divided by 2 and square it. Well, in our equation in standard form, our b is 12. We'll take that divided by 2 and square it. Again, remember to follow your order of operations. 12 divided by 2 is 6. 6 squared is 36. OK, so we're going to add 36 inside the parentheses and outside the parentheses. Now, the whole point we want to do is add it inside the parentheses. That's going to create our perfect square trinomial. But the important thing is we need to make sure we subtract it. Otherwise, our function would change in value. Right? And let's think about that in kind of maybe some easier terms. If you had the function f of x equals x, well, if you add 1, now that's a different function. But if you take f of x equals x and you add 1 and subtract 1, adding 1 and subtract 1 just kind of undo each other, right? It's still going to produce the same function, f of x equals x. So if I'm going to add 36, I have to make sure I also subtract 36. But just the importance is we want to make sure we add that 36, that value of b divided by 2 squared, inside the parentheses, because now that creates a perfect square trinomial, where our first term and our last term are squared terms. And what's important about that is we can easily factor this into a binomial squared. Because if we were going to factor this, we'd say what two numbers multiply to give you 36? Sorry, what two numbers multiply to give you 36, but then add to give you 12? Well, that is going to be x plus 6 times x plus 6, which is the same thing as x plus 6 squared. And then plus 35 minus 36 is going to be a negative 1. Now, what's nice about this is now we have taken our equation in standard form and rewritten it in vertex form. And what's nice about vertex form is we can now understand exactly what the vertex is, because the vertex is simply just hk. Now, remember the formula is x minus h. X minus h. So whatever I'm subtracting from x is going to be my h. Well, in this case, I'm not subtracting anything. However, I could rewrite this as x minus a negative 6. Therefore, then I would be subtracting from 6. So if it's x minus negative 6 is the same thing as x plus 6, hopefully you can reason then that h is a negative 6 and k is going to be a negative 1. The reason why this is important is because a lot of students forget the transformations. Basically, that x plus 6 is telling us to shift the graph 6 units to the left for you. It's not going to the right. It's basically the opposite is always happening. Then the next thing is we need to determine the axis of symmetry. So for the axis of symmetry, that's going to be the line that's going to cut the graph in half. That's simply x equals h. Well, as we mentioned, that h is negative 6. So therefore, I'm just going to write x equals negative 6. Now, on to graphing. So on graphing, I'm basically going to have 1, 2, 3, 4, 5, 6. That's going to be my axis of symmetry. So I'll draw a nice little dotted line there. And now to go ahead and graph this, I'm going to graph this over here because it is important to understand what the parent graph of f of x looks like, or y equals x squared. The parent graph has a vertex at 0, 0. The first points 1, 2, and 3. When you go over 1, 1 squared is 1. 2 2 squared is 4. 1, 2, 3, 4. If I plug 3 in for x, 3 squared is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Then that axis of symmetry is at 0. And then so I can just reflect everything over the axis of symmetry. OK? Oops, I kind of went a little bit higher than I wanted to, but I don't want to mess up that equation. OK, so there you go, ladies and gentlemen. That's basically what the parent graph looks like. So if I have my axis of symmetry over here, I've now also moved my vertex, so -6 and then down 1. So now there is my new vertex. From my vertex, I'm basically going over 1, up 1, over 2, up 4. So I'm just going to follow that same pattern from here. Over 1, up 1, over 2, up 4. 1, 2, 3, 4. Then I can reflect those points over the axis of symmetry. And then I can just go ahead and connect. Now, we want to look at our domain and our range. When looking at domain and range, domain is, remember, is the set of all x values that are going to make up your function. So here we have a function. And even with an equation, we can still look at the domain and range. So the domain is going to be the set of all x values. So as you can see, this graph, it is continually to expand. So we write our domain from the smallest x value, which is going to be all the way to the left. Well, as this graph goes up, it's going to continue going up to the left. It's going to keep on expanding. So my domain is going to be all values all the way to -infinity. And as this graph is going to continue going to the right, it's never going to stop. So all the way to infinity. The range is the set of all y values. So in domain, we're looking how far left does the graph go to how far right. Whereas the range, we're looking for the set of all y values that are part of the graph. How far low does the graph go to how tall is it going to go, or how high? Well, you can see that the arrows are pointing up. So this graph is never going to stop going up. However, going down, you can see that the lowest y value, the lowest coordinate, is at the vertex, which is always going to be the case. Either from the lowest point or the max point is always going to be at the vertex for a quadratic. So the lowest y coordinate is going to be -1. So since -1 is a point on my graph, I'm going to use a bracket instead of an in parentheses. So it's going to be -1 going all the way up to infinity. And there you go. OK, so now let's go and get into the next one. And this one kind of comes into that step number 2 that I talked about, where we have a value now that's in front of our x. But we can still go ahead and apply the same process here. So in this example, I'm going to, again, group my first two terms, my quadratic, my linear term. Now I see, though, my a is not equal to 1. My a is now equal to -1. So what I'm going to do in this case is I'm going to factor out a -1. So by factoring out a -1, I'm now left with an x squared minus 4x minus 6. OK? Now I go ahead and still do my b divided by 2 and square it. Well, b in this case is going to be a -4 divided by 2 squared. Well, -4 divided by 2 is -2. -2 squared is a positive 4. So now I'm going to add that 4 inside the parentheses and outside the parentheses. So I have -1 times x squared minus 4x plus 4 minus 6, and then minus 4. Now, here's where it kind of gets a little bit tricky sometimes for students. So if you look at this, you guys know that I'm adding 4. But in reality, I'm adding a 4 that's being subtracted by -1. So remember we talked about if you're going to add 36, you have to subtract 36. But this is adding 36. In this case, though, you're not really adding 4. You're adding 4 that's being multiplied by -1. So if you're going to subtract 4, that -4 also has to be multiplied by a -1. You got to keep those equations equivalent. That's like saying f of x equals x. Cool. F of x equals +1, then you got a -1, right? Well, if I said f of x equals +1 times 2, then when I -1, I also have to multiply that by 2. This is the same case, except that -1, it's just sometimes it's kind of hidden. It's not really hidden, but it's implied because that's outside the parentheses. So that's telling you you have to apply distributive property. All of these terms are being multiplied by -1. Now we look into factoring this, where we again know we have a perfect square trinomial. And that perfect square trinomial is going to be what two numbers multiply to give you 4, add to give you negative 4, and that's going to be x minus 2. Because negative 2 times negative 2 gives you 4, negative 2 plus negative 2 gives you negative 4. So that's going to be x minus 2 squared. And then here I have a negative 4 times negative 1 is going to be a positive 4. Positive 4 plus negative 6 is going to be a negative 2. So now in this case, we have x minus, right? We like that. Remember the form, x minus h, x minus 2. So what are you subtracting from x? Your h, or your 2. So therefore, h is equal to 2. So my vertex in this case is going to be 2 comma negative 2, where my axis of symmetry is going to be at x equals h. So x equals 2. So now when I go ahead and graph this, I'm going to go over to 2, draw my axis of symmetry. Okay, then I go ahead and plot my vertex, which is at 2 comma negative 2. So I go over 2, down to negative 2. Now, the other important thing to notice is this graph is now going down negative 1. So instead of going over 1, up 1, now it's going down 1 to the left 1. So I'm going to go over 1, down 1, over 1, down 1, over 2, down 4. 1, 2, 3, 4. Over 2, down 4. OK, so now let's go ahead and get into the domain and range. Remember, the domain is going to be the set of all x values. Well, again, this graph is going to continue getting wider and wider and wider. So I can say the domain is going to be all real numbers, or from negative infinity to infinity. The range, again, remember, is the set of all y values. How low does this graph go? Well, in this example, the graph was stopped at negative 1, but it was continually going up. Well, this one, the graph is now facing down. So the lowest the graph's going to go is negative infinity. But the highest, again, it's going to go is the y-coordinate of the vertex. Well, again, let's look at the vertex. The y-coordinate is negative 2. So my range is going to be from negative infinity to negative 2, which is included. All right, so let's get into our last one here. So I won't erase that in. All right, so now, again, we're just going to do the same steps. Hopefully, you guys kind of follow me here. Group those. Now we need to factor them out. Here I had to factor out a negative 1. That was your a. Here you can see now a 3 is my a. So I'm going to have to factor out a 3. So when I factor out a 3, I'm now going to be left with an x squared minus 2x plus 25. OK, now I need to go ahead and complete the square. So I'm going to take my b divided by 2 and square it. So negative 2 divided by 2 is negative 1. Negative 1. Oh, I think I might have to change this problem, but we'll go and look at it. Negative 2 divided by negative 2 divided by 2 is negative 1. Negative 1 squared is positive 1. OK, so now, well, let's just write in there. Negative 2 divided by 2 squared equals positive 1. So now I'm going to have this, and I'm going to do 3. Yeah, that's OK. 3 times x squared minus 2x plus 1 plus 25, and then minus 1. Yeah, I'm going to go ahead and change this, because I did my calculations actually wrong. But everything I'm doing mathematically is fine right now. But I'm going to change what this, I'm going to maybe change the original problem. So anyways, we have x squared minus 2x plus 1. That's a perfect square trinomial because we created it. That can be rewritten now as, oops, I forgot. Since I'm multiplying this by 3, I have to multiply this negative 1 by 3, right? Don't forget that. I almost forgot about it because I was starting to think ahead. So remember, this 1, since you're adding the 1 and subtracting the 1, when you're adding the 1, that 1 is being multiplied by 3 via distributive property. So when you subtract 1, that negative 1 is also being multiplied by 3 via distributive property. So therefore, when factoring this, I now obtain x minus 1 squared. Let's just make these all black. And that's going to be a negative 3. Let's not do it. Let's just use 5. Sorry about that. I don't mean to mess anybody up, but I did my math wrong when I was originally looking at this, so I didn't mean to do that. So let's go ahead, and that's going to be a negative 3 plus 5 is going to be a positive 2. OK, so now, again, we're going to go ahead and identify our vertex. In this case, our vertex is going to be at h comma k, so that's going to be 1 comma 2. Our axis of symmetry is going to be at x equals h or x equals 1. So now when I go ahead and graph this, I'm going to go to over 1. I'm going to make a nice axis of symmetry. Okay. My vertex is at over 1 up 2. Now, here's where it gets a nice little interesting. You can see here I have this 3, and that's going to be changing what this graph looks. That's going to be a compression of the graph. So remember, that's going to be a, when you have that 3 on the outside, that's going to be a horizontal compression or a vertical stretch. So how is that going to affect a graph? Well, basically over here, we always went over 1, up 1. Or if it was negative, we went over 1, down 1. Well, we're still going to do the same thing. But when we go over 1, up 1, what we're going to do is we're going to be multiplying that value by 3. Because basically we go over 1, up 1. So now it's going to be over 1, up 3. We went over 2, up 4. But now we need to multiply that by 3. So it's going to be over 3, up 12. So you're going to keep on multiplying all those values by 3. So to do this, I'll go over 1, now up 3. 1, 2, 3. So I go over 1, up 3. 1, 2, 3. Over 1, up 3. And then over 2, up 12, or over 2, up 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you can see how doing that has now really shrunken, it really compressed my graph horizontally. All right? But the values and everything else is still the same. But I want you to compare that into. So basically, instead of going over 1, up 1, you're going to go over 1, up 3. You're going to go over 2, up 4. You're going to need to multiply 4 by 3, which would be over 2, up 12. Now let's go ahead and look at our domain range. Even though this is much skinnier, it's just going to take a little bit longer for it to reach negative infinity and infinity. So our domain is going to be negative infinity to infinity. And our range now is going to be, the lowest point now is going to be the lowest point of our vertex, which is going to be at a positive 2. And the highest value that the graph is going to go is infinity. So there you go, ladies and gentlemen. That is how, there you go, ladies and gentlemen. That is how you graph a quadratic when you have it in standard form and by rewriting it in vertex form. Thanks.